So the functions of f and g are twice differentiable. The table shows the given values of the functions in the first derivatives that select values of x. So in this one, you're letting h equal to f of g of x, and you're trying to find h prime of 7. So this is a function within a function, so you're going to have to use chain rule, which means that h prime of x is equal to f prime of g of x times g prime of x. So plugging in 7 into these values, you're going to get 0 when you plug it into g of x, and then so you're going to get f prime of 0, and then when you plug in 7 into g prime of x, then you'll get 8. So you're getting f prime of 0 times 8, which also equals to 3/2 times 8, which equals to 12.
So in this problem, it's giving k prime of x as f of x squared times g of x, and it's asking if k is concave up or concave down at x equals 4. So you take the derivative of the k prime of x equation using the product rule and sort of chain rule, and you get g prime of x times f of x squared plus g of x times 2 times f of x times f prime of x. And then plugging in 4 for each x, you eventually get to -40, which is less than 0, which means that this function is concave down at x equals 4.
So in this problem, it defines a function m of x equal to 5x cubed plus the integral from x to 0 of f prime of t. And the questions ask to solve for m of 2. So the integral of f prime of t equals to f of t. And plugging in 2 for each x, you will get 5 times 2 cubed equals 40 plus f of 2 is 7 minus f of 0 -10, and the answer will be 37.
So the question D asks if the function m from part C is increasing, decreasing, or neither at x equals 2. So to do this, you must take the derivative of this m of x function, which means you have to take the derivative of this 5x cubed plus the integral from x to 0 of f prime of t dt function. So taking the derivative of the 5x cubed part, you use power rule, which is 15x squared. But taking the derivative of the integral part, you have to use the second fundamental theorem of calculus, which states that if a certain function like a of x is equal to the integral from x to 0 of f of t dt, then the derivative of a of x is equal to f of x. So then plugging in 2 for this new equation, you get 15 times 2 squared plus f prime of 2, and you get 60 minus 8, which is 52. And this means that the function at x equals 2 is increasing because m prime of 2 is 52, which is greater than 0.